All right, we're going to look at Wednesday's daily math first. So number 1 asks you which model correctly represents the problem. So you have some fractions. This time they're all subtracting fractions. And it wants to know which one has the correct answer and is modeled correctly. So if we're going to add or subtract fractions, what has to be the same before we can do anything? What has to be the same, Olivia?
The bottom number.
The bottom number. The denominator has to be the same. And in all 4 of our options, the denominator is 8. So we're ready to subtract. The first one, we have 6/8 minus 3/8. What is 6/8 minus 3/8, Cash? We said the denominator's the same. So what do we do with the top numbers? Okay, 6 minus 3 is 3. What about the bottom number? What's the bottom number going to be, or the denominator? 8. It stays the same. So 6/8 minus 3/8 is 3/8, not 5/8. So we know option 1 is not correct. Option 2 says 6/8 minus 1/8. Dylan, what is 6/8 minus 1/8?
5/8.
5/8. 6 minus 1 equals 5. So we need to look at our model. There's 1, 2, 3, 4, 5, 6 pieces shaded. There's 8 pieces in the whole thing. So did they start by shading 6/8? Okay. Did they take away 1/8? They did. So option 2 is your correct answer. All right. Let's look at number 2. They give us a rectangle. It asks what the length of L is. We know the area equals 42 square inches, and we know that the width is 6. So how are we going to find the length? What are we going to do, Ansley?
Do 42 divided by 6.
Okay. 42 divided by 6 is going to equal the length, because area, which is 42, equals length times the width. And you turn that around into a division problem. And what would our answer be?
7.
Length equals 7 what?
7 inches.
Inches. Very good. Correct answer is 7 inches. Okay. The next question, we're looking for the missing information for the equivalent fraction and then putting those in decimal form. So if we have 90 100ths, how many tenths would it take to have the same amount shaded, Jaden? 9, you're exactly right. So A is going to be equal to 9. How could we show that using math? What would we do to show that 90 100ths is equal to 9 tenths? How could we make 100 into 10?
Minus 10. 100 minus 9.
Okay, how about using division or multiplication?
Divided by 10.
Divided by 10, exactly. If we did 100 divided by 10, we would get 10. What would happen if we did 90 divided by 10?
Get 9.
We would get 9. That proves our equivalent fraction. So A is equal to 9. All right, so for B, we need to find the decimal form of 90 100ths. What's the decimal form of 90 100ths going to be, Jacob?
0.90.
Very good. We have 0 wholes, the decimal point, and then we would have 90 hundredths. So we would have a 9 and then a 0 in the hundredths place. Very good. How about 9 tenths? How are we going to write that, Owen?
It would be .9.
Very good. We would have 9 in the tenths place. 0, a decimal point, and then 9 would be the next number. All right. Now we're looking at some fractions. And they're modeled, or I'm sorry, some decimals that are modeled, and we want to know which one is modeled and solved correctly. So let's look at option 1. Option 1 shows 60 hundredths. How do I know that this is 60 hundredths? How do I know that, Jacob?
It's in like hundreds.
Yeah, it's in the hundredths. That second place value to the right of the decimal is the hundredths place value. So I need to look and see if I have 60 of the 100 squares colored in. There's 10, 20, 30, 40, 50, 60. So that's correct. Okay, what do I have here? Thank you. What's this decimal?
6.
6 what?
Tenths.
6 tenths. I should have 6 of the 10 shaded. There's 1, 2, 3, 4, 5, 6. So is it shaded correctly?
Yes.
Is 60 hundredths greater than 6 tenths?
No.
Equal to. Why are they equal, Jaden? Exactly. Even though this is broken into smaller pieces, the hundredths has little tiny squares instead of the big bars. It's still the exact same amount, isn't it? Okay. So let's look at this next one at option 2. I've got 60 hundredths again. That zero's in the hundredths place value. Does this show 60 hundredths?
No.
Oh, that shows 6 tenths.
And the other one shows 60 hundredths.
Exactly. The second one shows 60 hundredths. Okay, so we know that one's not correct. Let's go down here to option 3. What do you think about option 3, Harper?
I think that's right.
Okay.
Because it has the equal sign.
It has the equal sign,
Correct.
and it's shaded correctly. There's 60 100ths shaded and 6 tenths shaded, and it shows that those are equal. So option 3 is your correct answer. All right, and then the last question that you had on Wednesday's Daily Math asks you to identify the fractions on the number line. So let's look at our number line. We have a number line between 0 and 1. So we need to know how many equal pieces there are in that one whole. Do you agree that that's one whole between 0 and 1? That's 1. Okay. So let's look and see how many equal size pieces there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our number line is broken up into what size pieces? Ninths, exactly. So we could go through and we could label them. The first one would be 1/9, then 2/9, then 3/9, 4/9, 5/9, 6/9, 7/9, 8/9, and one whole is equal to 9/9. All right, so let's look at our answer choices. First, we have 3/12. Does that make sense for what we have so far? No. Okay. 8/12.
No.
7/9. Do we have one that's 7/9?
Yes.
Which one is 7/9?
The D.
D. So D, we can go ahead and mark D as 7/9.
But there's not a 6.
Okay. Then we have 4/12. We don't have anything on here that's 4/12, do we?
No.
Do we have 3/9?
Yes.
Which one is 3/9?
B.
B is equal to 3/9. All right, and then we have 2/9. Do we have one that's equal to 2/9? Which one? A. A is 2/9. So we're still missing C. We have C is 6/9. So how in the world are we going to figure out an equivalent fraction to 6/9? Let's look at 3/12 first. That's our first answer choice. So let's just look at 3/12. 6/9 and 3/12. And let's see if we can make those become equal fractions. Can I get 6 to become 3 by either multiplying or dividing?
Yeah.
What would I do? Okay, so 6 divided by 2 would equal 3. Okay, so if I divide 6 by 2, I also have to do 9 divided by 2. Can I do 9 divided by 2 to equal 12? Does 9 divided by 2 equals 12? No. So I know those two are not equal. It can't be 3/12. Okay. So let's look at 8/12. 6/9 equals 8/12. Let's see if that works. Can I do anything? Can I multiply or divide 6 by anything to get to 8? No.
No, you can add.
Okay, I can add, but to find equivalent fractions, we have to either multiply or divide.
4/12. That's not equal.
So, what can we divide both 6 and 9 by? What common factor do they have? 6 and 9.
3.
What is it, Harper?
3.
3. So if I did 6 divided by 3 and 9 divided by 3, what would that get me? What's 6 divided by 3? 2. 9 divided by 3 is 3. So we could say that 6/9 is equal to 2/3. Do you agree with that? Okay. So let's see now, can we make 2/3 into 8/12? Could we multiply or divide 2 times anything or divide it by anything to equal 8?
2 times 4.
2 times 4. So if 2 times 4 gets me 8, I also have to do 3 times 4. And 3 times 4 equals 12. So it took us a little bit to get to that, but we could prove that 6/9 is equal to 8/12. So C is equal to 8/12. That was kind of a tricky one. I won't give you a tricky one like that on your quiz tomorrow. Okay? It is. And that's one of the reasons that I've been telling you that you're knowing your multiplication and those multiplication facts quickly is really going to help you, because it doesn't take quite as much work to get to that. Okay? All right, now for Thursday's daily math. The first question asks you which model best represents the answer to the problem 1 and 7/9 plus 1 and 1/9. What does 1 and 7/9 mean? What does that mean, Olivia?
1 whole and 7.
1 whole and 7/9 more of another whole. Okay. What does 1 and 1/9 mean, Christopher?
It means 1 whole and 1/9.
Very good. So how many holes do we have? If I put my holes together, how many holes are there, Dylan?
There are 2 holes.
2 holes. If I put my fractions together, what fraction of another hole do I have?
8.
8 what?
9. 8/9.
8/9. So I'm looking for the model that shows 2 and 8/9. Which one is that? Which one is it, Christopher?
Number 3.
Option 3. Option 3 shows 2 holes shaded and 8/9 of another. Why is option 4 not correct? It also shows 2 and 8/9. What's wrong with it?
It's because the top of it is it's subtracting that, taking it away.
Yeah,
from
it's
the
crossed
other.
out. Same thing on option 2. It also has 2 and 8/9 shaded, but the 8/9 are being taken away. All right. Let's look at number 2. On number 2, it tells you that angle DEF is a 90-degree angle, and it wants to know the measure of angle GEF.
Yes.
What is it, Brayley?
So I took away, so you know it's 90, so I took away 30 from the 90 and got 60.
Okay, why did you take away 30 from the 90?
Because DEF is 90.
Uh-huh.
And GEF would take away that 30 because you're not using it.
Yeah, here's this 30 right here is part of the big 90-degree angle, but we don't need that for angle GEF. Very good, Brayley. The correct answer is 60 degrees. Okay. All right, the next one, we're classifying this triangle. Remember, there's 2 ways we can classify or name triangles. One is by the angles, and the other is by the sides. So let's look at the angles first. What are the 3 types of angles? Tell me one type of angle. We just had one above. It was 90 degrees. What's that called? We have, if we have a 90-degree angle, what's that called? 90 degrees.
Right.
Right. Right triangle. Okay. What was another one, Olivia?
Obtuse.
Obtuse. What does obtuse mean?
Bigger than.
Bigger than 90 degrees. And the other one is
Acute.
acute, and that means smaller than 90 degrees. So if we look at our 3 angles that are inside this triangle, do we have any right angles? No. Do you see any obtuse angles? Any angles that are bigger than 90 degrees?
No.
No. So all 3 are acute angles. So what would we call that? If all 3 of the angles are acute. What do we call it, Jaden? All 3 of the angles are acute. All 3 angles are acute. If all 3 of them are acute, then it is a acute triangle. Okay? All 3 are acute, so it's an acute triangle. Now we need to look at the sides. So we can have, if all 3 sides are the same length, then it's what kind of triangle? Alright, so if all 3 sides are the same, then Amy said it's an equilateral triangle. What if 2 sides are the same length?
Two sides. Isosceles.
It's an isosceles triangle.
So I got one.
What if there's no sides that are the same?
Scalene.
Scalene. Alright, so it's kind of hard to tell, but you can kind of just use your fingers to measure and judge. So, got about this much. And are those two equal?
No.
Here to here. Are those equal?
Yeah.
Okay. Goes from the end of this to right there where my finger is. If I put it on the other side, is that the same?
Yes.
Yeah. So two sides are equal. Is the bottom equal?
No.
No, just the top two sides. So if two sides are equal, that's what kind of triangle? Isosceles.
I got one triangle on here. Yeah.
Okay, we'll fix it. So it should be an acute isosceles triangle. All right?
I did the isosceles, but not the acute.
Okay.
I did
All right. So remember, if all the angles, if there's no acute angles, I'm sorry, no obtuse angles, then it's an acute triangle.
Because sometimes I forget.
Is it acute? It says acute. It's really
Okay, well, I'll fix it. All right, let's look at number 4. All right, this one was kind of tripped a few people up, so let's look at what it says. Earl sold 4 houses in March and 3 houses in April. In May, he sold twice as many houses as he did in March. How many houses, we're going to use the variable H for houses, did he sell in March, April, and May? So tell me what I know from this problem. What's one thing we know, Olivia?
That he sold 4 houses in March.
He sold 4 houses in March. What else do we know?
And he
Jacob.
and in March in April he sold 3 houses.
Okay. 4 in March, 3 more in April, and then what happened in May?
He sold twice as many houses as he did in March.
Okay, so how would we represent twice as many?
Like, you do, like, 4 times 2.
4 times 2. Okay.
And then
So,
plus the other things.
let's just look at this first line. We're going to ignore the rest of it. We know we're solving for H. That's the number of houses he sold in the 3 months. And then we have 2 variables. We have A and A, which is the same number.
Yep.
And we have B. So A times 2. What would we need to multiply by 2, Christopher?
4.
4. Why do we need to multiply 4 times 2?
Because it's referring to May is twice as many as March, which is 4 houses.
Exactly. So he sold 4 houses in March, 4 houses, and another 4 houses in May. So we would multiply that by 2. So A both times equals 4. What is B equal to, Ansley? 3. Very good. So we've got
I see how it's from because I forgot.
4, 4, and 3. Now we're ready to go to the next step. So I'm looking at what I have. When I'm working a problem that has more than one step in it, are there any parentheses to tell me what to do first? No. So I look for any multiplication or division. Do I have any multiplication to do?
Yes.
What do I need to multiply, Amy?
4 times 2.
4 times 2. I'm going to do 4 times 2, which equals what?
8.
8. So that's my next step. 4 times 2 is 8. And A is still equal to 4. B is still equal to 3. Do I have any more multiplication or division to do?
No.
No, I do not. So now I'm ready to add or subtract, whichever is in my problem.
Yeah.
8 plus 4 plus 3 is what?
15.
15.
I forgot.
So D equals 15. He sold 15 houses.
I forgot that it said it to add all of that. All of them up together.
Okay.
That's how I got the last one wrong.
Just remember, when you have problems like this that are more than one line, each line is the next step. What you would do next when you solve. Okay? Don't let that trip you up and confuse you. We're starting with the top line, ignoring everything else. To get to the next step down, the next line, I'm just going to solve the first part. Everything else stays the same. Then, to get to the next step, I'm going to solve that part. Okay? Does that make a little bit more sense? Getting a little bit more comfortable with that? I know it's still a little confusing.
Yeah, almost it actually made perfect sense.
Well, good. Alright, so let's look at this last one. We're multiplying 9 times 2/5. So I'm doing 2/5 9 times, or 9 groups of 2/5. How else can I solve 9 times 2/5? What else could I do, Amy? How would I solve to find what the answer is?
You would do 2/5 9 times.
2/5 9 times, okay. So my problem would look like 9 times 2/5. So I could add 2/5 9 times, or what could I multiply?
9 times 2.
9 times 2 gets me what?
18.
18. And how many fifths do we have? Or, I'm sorry, what's our denominator?
5.
5. The denominator stays the same. So
18
9
fifths.
times 2/5 is 18 fifths. So I can either look at this and count and see which one has 18 fifths. Or I can also make it into a mixed number to make it a little bit easier to see. How many 5s are there in 18?
There are 3.
3. And how many more would I have?
You would have 3 left
I'd
over.
have 3 left over. If I use 3 wholes, that would be 15 of my fifths. And then there's 3 more to get from 15 to 18. So that's 3 and 3/5. Which one of our models shows 3 and 3/5?
Number 3.
Option 3 is the correct answer.
That's what I did, but I added 2 to that.
Okay, so you added 2
And then
9 times to get your answer.
And then I took away the 5s from all of it.
Okay.
I had 3 left over.
All right. Okay, questions about today's math?